Hi, everybody. I hope you can hear me clearly. Um, so, my name is Tom Ogoma. I come from Nairobi, Kenya, and I work for a company called Andela. Andela, at Andela, I work for a company called Mastercard. So, it's sort of a partnership between the two companies. And in Mastercard Labs for Financial Inclusion, which is a part of Mastercard that I'm working at, we do projects for financial inclusion. So basically, trying to get access to financial services to those who are at the bottom of the financial pyramid. Basically, we're talking about people who have no access to bank accounts and things like credit. So just trying to bring financial services to be accessible to them. So that's me in a nutshell and what I do. Today, I'm going to be talking about implementing RESTful APIs in Golang. It's sort of a mini journey of what my experience has been in learning Golang and trying to implement real world applications using the Golang programming language. So, just a bit of a background to talk about how I started my Golang language. Um, Straight out of campus, basically the idea is you've learned a bunch of languages. I had learned Java, a bit of Python, and different other bits of languages. And then there was this new exciting programming language called Golang out there. And typically, if you look at the devices we use and the applications we use, we follow one model, which is we normally have some connection somewhere, and then you have services providing servers providing services to different applications in various mediums like you have computers, laptops, mobile phones, and desktop PCs. So generally, when you're talking about providing web services, you're talking about things that reside on the server side, and Golang looks like a very good candidate for doing that. So today's talk will generally be touching on the journey in getting to a point where you can create a web service, basically APIs, using the RESTful approach. So if I may get a feel of the room, how many of us here are beginners in Golang? All right, it's a good number. How many will consider themselves intermediate to advanced? Awesome. So I think the talk will benefit all of us, especially the beginners, and hopefully spur some sort of conversation for those of us who've advanced in the Golang track. So diving in, I'm going to try and get into a bit of detail. So just talking about a RESTful service before we get into the Golang aspect of it. When you're talking about REST and providing services to different clients, you need to be able to do a bunch of things internally in your application to be able to service these clients. So you need to handle HTTP requests for the HTTP protocol. You also need to be able to process authentication and authorization, maybe allow some users to do some things and others not to use some things, and also make sure that the person who is doing the access is logged in to the system and has authority. And then, of course, the business logic that you want to do. And that sometimes involves saving and retrieving data from the database. And on top of all of that you want to do in order to achieve your service, you also need to be able to test and configure it for various environments. So we're just going to be talking about what it takes to put those components together and get a RESTful service API running. On top of doing the internal stuff that you need to do to develop your application, you also need to come up with a way of making your application available to different users. And once it's available to different users, you also need to start thinking about things like, will it be able to scale when you get the right number of users or a big number of users? As well, you also need to think about things like support and downtime and how you're going to monitor your service and make sure if something goes wrong, you're able to know and things like that. So this talk sort of also tries to think about how you design your RESTful application in a way that allows you to sort of not necessarily have to think so much about it, but have it at the back of your mind so that when the time comes for scaling or the time comes for managing some of these things, you're in a good place to change small components and not necessarily have to do a complete rewrite of your code base. Right, so I'll just get straight into it. The first thing we spoke about when we were talking about RESTful application is that we need the application to be able to handle requests. And for this to happen, we need a server. So Golang provides the internal HTTP package, which is pretty good for these kinds of requests because it handles all the concurrency for you, all the incoming requests, the workload, and sort of allows you to just think about how you're going to handle each request once it comes in, do your business logic without thinking so much about how to handle multiple incoming requests at one go. So it's pretty easy to set up your Golang application to listen and serve at a specific address on a computer. So using the internal HTTP package, you can call listen and serve, provide an address, the port maybe, or a more generic address, and a handler. There are various ways and configurations of doing this, but we won't go into depth on how to do that today. But typically, you're allowed to do that either using HTTP or HTTPS. For HTTPS, you would have to do listen and serve TLS, providing various configurations. That is the certificate file and the key file that will contain the certificate from your certificate authority, which you will use to perform TLS on the requests. Typically, for my services, I normally do listen and serve. I use this because this allows me to put a proxy or a gateway in front of my services. Typically, I would use Nginx. Some guys would use Apache. And also, this allows you to sort of also deploy to various cloud services that we have available to us, the likes of Heroku, Google Cloud, and AWS functions, Lambda. So typically I will use that, but if you want to handle everything internally in your application, listen and serve TLS is also available for that. So once you have your server up and running, the next thing you need to think about is how you're going to manage the requests that are coming in. So with RESTful applications, we have various verbs and various paths that would allow our application to know how to route the request so that the proper handler can handle that request. So one thing that is provided by the internal HTTP handler is the inbuilt HTTP package for routing. And the most common way that I use the HTTP package for routing is using the handle func. The handle func allows you to sort of use the handler func, which is sort of a stub for the handler interface. It's a quick way to use the handler interface, although alternatively you can use http.handle, which will do the handling for you. So if you're using the library, the Go package library directly for HTTP handling, there is the drawback that you have to sort of think of how you're going to do your routing, how you're going to manage all the paths and match them to the request that you want to do onto, map that onto a method or a function that will handle the request. And it's pretty straightforward when it comes to handling the verbs. Like there's an example up on the screen where you can use a switch statement to switch between, for the route persons, switch between a post request and a get request. But then it can get complicated when you have more complex or dynamic paths and things that you want to handle dynamically. But it's still doable. Normally, for my applications, I will use a third-party library. In the next slide, I have an example of using Gorilla Mux for the same requests. And this allows you to, in a more readable way, sort of route your requests depending on dynamic paths, and as well use all the functionalities that you have available on the HTTP package. The good thing with most third-party libraries when it comes to HTTP routing or multiplexing is that they try to work as close as possible to the handler func interface. So you can easily switch between and try different libraries until you get the best fit. So the example on the screen is one by GorillaMax. So I instantiate a new router at the top, and then from there, given different paths, as you can see, I'm trying to dynamically allocate a space for the ID when you're fetching from the person's route or inserting. And then, depending on the method, I can route that to the handler func that implements that interface by the HTTP inbuilt HTTP interface. The methods in yellow are just pre-implemented methods that you can pass because we know functions in Golang are first-class citizens, so you can pass a method to your function like that. One of the drawbacks of using most third-party libraries comes when you're doing debugging or you're sort of trying to figure out why a route matching is not working. Especially if you're onboarding someone new into your project, they sort of have to learn about the internals of that library to some extent. For example, when using GorillaMax, the order of the routes that you define and provide to the multiplexer really matters. So if we were to reorganize these parts so that the two at the bottom go to the top, suddenly the get for person wouldn't work for the specific ID. It would only be routed to the get for a list of persons. That is because the multiplexer would go with the most general match, and whichever one comes first is the one that will be matched first. So that is the biggest drawback with using libraries. Sometimes when it comes to testing and debugging, there's a challenge in terms of how do you figure out, it's not very intuitive in terms of finding out where the problem is when it comes to the routes. Yep. So ideally, I will use either the internal HTTP package or a third party. I came to fall in love with GorillaMax, so I usually use that as my default, unless I need something different. Just taking us back to what a RESTful service would entail. Now that we have a HTTP server up and we are talking about routing different requests to different handlers, how does Go enable us now to do the business logic to sort of handle all of these incoming requests and do what we wanted to do with the requests, basically just serve our clients? So there are various concepts that we're going to talk about that sort of are enablers in the Go platform to us to be able to do this in a way that allows us to authenticate, authorize, log data, and process our business logic without having to repeat ourselves, keeping our code dry, testable, and at the same time scalable. So I'll just move into the different concepts. Let's first start looking at logging. So when it comes to logging, Golang has a logger package that allows you to log. It's sort of a global package. So when I was starting to develop my programs in Golang, I would have log.printf or println all over my code. But then sort of that creates a problem at some point in time, because eventually you get to a point where you want to manage your logs. You want to separate the information logs from the debugging logs. Different cloud services want you to log in different ways. So I sort of learned eventually that it's better to abstract that, have an interface as a requirement. So you're sort of doing inversion of control at this point. You need to provide an interface for a logger. Then whoever is instantiating that struct or the handler for the business logic that you want to do will need to provide a logger. And then that now allows you to control how your application does its logging on its end. So packages that log data should have a logger as a dependencies. And then through my learnings, I've learned that eventually, if you have a handler for a request and the handler is dispatching events to different methods or functions that will do different things. Eventually, the logging will happen at the handler level because all this information, when a call is made to a service that does some business logic, will either return an error, the Golang way, or a successful response to the handler. And the handler can then thus do the logging on its end. Where I find myself doing logging other than from the handler point is where I have Go routines that may run concurrently to the application and maybe runs at specific runtime intervals. Then it will require a logger interface and then do its own logging at its own time. So because it's sort of a handler on its own for that. And then one thing to note is we should try to keep our logs as detailed as possible, but at the same time succinct. That means that you don't want to be so verbose as to maybe mess up your metrics when you're monitoring your data or when you're trying to debug and looking for specific logs. But at the same time, you want to log everything that happens, sort of like everything that happens that is important so that you can be able to trace what's going on your application. The next bit is error handling, which is sort of very related to logging because most of my logs are either info logs or error logs. Again, when it comes to error handling, because it works hand in hand with logging, I try as much as possible to have all my errors that are thrown by the function that I call in the application to sort of bubble up back to the logger, but contain a trail of the context for the error information that has been generated. So some of the things that I want to talk about here are what Go allows you to do. We all know that we can ignore return values by different functions in Golang. So you can ignore an error. Don't ever do that. So you will never find an underscore in my lines of code. And it's normally a flag when it comes to code review. We need to handle all errors. Then the error message that is being generated from the error handler, where you're checking if error is not nil, needs to contain contextual information about what you are trying to do. That is like I was trying to save something in the database, and then also the error that is bubbling up back to the calling function. On top of this, when you're passing back the errors and using such a format, this is by the internal FMT package in Golang that allows you to propagate an error back up the pipeline. You can also use third-party libraries that allow you to be able to trace better the error that you are getting. So different libraries will give you different levels of information. Some will even tell you the line number that you are logging the error at, throwing the error at, and things like that. And of course, by the time the error gets back to where it's being handled, you want to either log that or handle it gracefully, depending on how the nature of the business logic that you have. Right. Next, we have the context package. This one is a very interesting bit because it sort of gives us the power to pass information between different bits of our handler logic, but it has its own catches, sort of like it tends to be overused or misused or underused in some cases. Typically in my web applications, I would use the context package to propagate different things like timeouts and information that is specific to the request that is being handled. So for example, if I'm trying to fetch information about a person, when the handler is getting the request for the first time, I will probably get a transaction ID that will be carried through that entire request, and I will hold on to that. Things you don't want to hold on the context package are things like your database handler connection, or your general information logger. So you don't want to hold on to that. Yeah, the items you want to pass through your context need to be very specific to the request that you are passing. Now, here's an example of how I would use the context package. So we have a request handler that does something useful. That's the handler func. It implements the interface for that stub. So we're trying to create a logger that is very specific to this request. So we generate a transaction ID in line 94. And then once we've generated that, we come up with a logger. So this one is coming from Logras, one of the logging packages that is available on Golang. You can also as well use the internal logger. And in line 96 is where we're extracting the context from the request. So that's r.context. And sort of inserting our logger into the context so that down the line, whoever is accessing this request can be able to use that logger to do further loggings. And this will hold on to the transaction ID for that request. It's important to be very careful not to pass the application level logger to the context, because you might end up with resource lists, similar to passing the database connections and other things that live through the life of the application. Right. Another construct that is available to us in Golang is middleware. Middleware sort of allows us to organize our code in such a way that it is very dry and very readable in terms of having repeatable things being done by different handlers for different scenarios. So here's an example of an auth guard, if you might call it that. So it guards against JWT. The signature for middleware functions is typically it takes the next handler function that should be called down the line, and it returns its own handler function that handles the request immediately the moment it comes in. So we return that function, and what you're trying to do in line 90 is read a token from the request. So that method will read that token, and if there's an error handling that, then we call a handle error method that will handle the error on our behalf. So trying to keep the code dry. And once we get the token, we try and validate that the token is valid in line 95. Once validated, we then go ahead and put the claims for that token inside the context. So this is another way you can use the context to propagate information. So down the line, if any other part of your application needs to check against the claims, they don't have to read the JWT and sort of validate it. Since that has already been done, they can just check the claims to see if the person who's trying to access the service has the rights to access whatever service they're calling. So next we call serve HTTP. So middleware sort of allows you to abstract this, and any handler that needs the JWT to be validated against will need to use this guard in its processes. So let's have a look at how we will use that. So here's a handler that handles insert persons. And so it takes a multiplexer router from Gorilla Max. And for any post method, it tries to handle the request using the handler func. So we call the prepare logger middleware in line number 40. After calling prepare logger, which will prepare our logger on our behalf and put it in the context, we also call guard JWT, which sort of tries and validates the jot that is contained inside the request. And finally, we handle our request at the bottom. So if we get to the point where our function is called in line 43, then we know everything is good in terms of our logger is ready, our jot has been validated, so we can do whatever we need to do with it. If we need to check the claims, we just need to open up the context and read the values from it. Right. So once you have all those constructs put together, again, we had talked about this a bit earlier, just trying to race a bit to save on time. But when you're implementing your application, it is important to have inversion of control in mind. That is dependency injection. Basically, anything that your application depends on, like logging, database access, or calling other services, they need to be defined as interfaces that will be implemented by some other part of your application. That way, it allows your application to be able to say what it needs. It sort of creates a contract that your application can communicate to other parts of the application. At the same time, makes your application very much testable. So people coming to sort of extend or add on to the application, it makes it also very readable. Yep. So very testable code. You can easily swap libraries if you're using interfaces, because at the point of your application consuming the database or any other library that it needs, you can easily swap that with anything that implements that interface. And then it forces you to think about separation of concerns. Also, the code becomes very testable. And then while we are on the topic of inversion of control, when you're implementing structs or packages that contain implementation for specific interfaces, I tend to use constructors over instantiating the structs directly. The reason for this is constructors allow me to sort of validate the code that is contained inside, basically the parameters that are being passed in the constructor, and then initialize the struct. So you'll find that most of my structs have package private members, and then you have a new constructor construct in there that allows you to generate this. So I have an example of trying to create a buyer API sort of struct, and you can see DB is one of the dependencies for a buyer, but we don't, instead of sort of like allowing the client to this buyer to instantiate DB directly, you have to call new buyer in order to pass the DB, which will be validated if it's actually not nil, and then the buyer is constructed. So it ensures that your structs are in a valid state by the time they're being used by the application, and you end up not having so many panics in your application, right? So, like I said, they enforce a valid set for struct before use, but the downside is that in Golang, there's no enforcement that a constructor has to be called. So someone might be lazy and just instantiate that struct and use it as is. So that's one of the downsides to that. Something you can catch in code review if you decide to enforce that. Right. So finally, I want to talk about organizing the code that you will be using. Typically, what I would use is this structure where you have the CMD, contains the main functions for different deployment strategies that we want, whether running it on command line or as a Heroku deployment or G-Cloud or a microservice on its own. And then we have the internal package, which sort of contains my dependency injection logic and anything internal that is very specific to the application that is about to be run. So this will sort of bootstrap everything, put everything together so that the main functions in CMD can easily just use this in their logic. So you end up having the main functions in CMD, many of them, but the logic in there is very little because Bootstrap sort of collects that for you. And that allows you to be able to deploy to multiple services without having to think about how to bootstrap for each and every service that you are deploying to. And then finally, PKG is just sort of like the collection of packages that, libraries, that we are going to be using in our application. So all our handlers, the business logic, and everything that is shared across the application is over there. So if you manage to separate the packages in PKG as per domain logic, then it gives you the advantage in that if you want to expose your library, maybe it becomes good enough to be used as a public API, you can easily just remove the directory and provide it to your clients. So, yeah, in a nutshell, once you've organized your code and sort of have everything put in place, your main function should be as brief as this. So that allows you to have many main functions that can work with different configurations for different services. So yeah, I'll leave this up. I'm saying in the interest of time, I think I have like 3 minutes, so I can talk about it. So here we are just instantiating a logger. Then we are trying to read the configuration values. We read the configuration values at this point rather than in the Bootstrap because different deployments will want you to do it differently. So Heroku might want you to use environment variables. In your own server, you might want to use a config file, and so on and so forth. So you want to read the config values from your main application. And then once you have these two pieces of information, again, the logger again as well, since because of the environment, Google Cloud might want you to pass a request inside the logger every time you want to log something. So you want to instantiate that from your main application. Then in line number 20, I instantiate a new HTTP handler. So Bootstrap will sort of put together all the dependencies for a HTTP handler and package them into the HTTP handler struct right there, excuse me, and then pass that HTTP handler to Golang HTTP package, tell it to handle that with the handler, and then listen and serve at the configured port. So that's at line 25, and if the service fails, we just log fatal on error, basically just kill the service saying that something went wrong while serving to that port. So typically this is the sort of structure you would have in your main files once you're done with the code. So thank you.